Welcome. Welcome in the class of fluid mechanics. Today, in this session, we are going to discuss about the manometer, its definition, and different types of manometer. So let's start with what is manometer. So you can see the slides here also. This is a manometer. So how can you define this manometer? It is the device that is used for measuring the pressure at a point in the fluid. It is the device that is used for measuring the pressure at a point in the fluid by balancing the column of the fluid, either by the same or another column of the fluid. So basically, it is a device that used for measurement, that used to measure the pressure at a point in the fluid. So it is by balancing the column of the fluid. When you see the picture, it will be more clear. Suppose this is the flow in the pipe, and we want to measure the pressure at this point. So we connect the glass tube here like this. So this is your called the manometer. This is one type of manometer. See here the types of manometer. Types of manometer is a simple manometer and differential manometer. When you go to this types of manometer, then we will see the picture and it will be more clear to you. For the time being, you just understand this manometer is a device that used to measure the pressure at a point in the fluid by balancing the column. This is the manometer. Now we are moving to the next slide. Types of manometer, simple manometer and differential manometer. What is the simple manometer? Simple manometer, the simple manometer, it consists of a glass tube. Simple manometer is a type of manometer that consists of a glass tube. It consists of a glass tube having one of its end connected to a point where the pressure is to be measured, and the other end remains open to atmosphere. That means a glass tube having the two ends. One end is connected to the pipe where the pressure is to be measured, and other end is remains open to atmosphere. So simple type of manometer generally classified as it may be either the piezometer or YouTube manometer, or others it may be the single column manometer also. These are the types of simple manometer: piezometer, YouTube manometer, single column meter. Now I'm coming back to the definition of this simple manometer. So this is type of manometer that used to measure the pressure at a point in the fluid. So it consists of what? Glass tube that have one of its ends connected to a point where pressure is to be measured, and the other end remains open to atmosphere. So here I'm using the annotation. See, so this is your pipe flow. You want to measure the pressure at this point, so connect this point to the glass tube. This is your glass tube, like that. This. So this is your liquid that will rise in this column. Suppose at this level liquid rise. So what is this simple manometer? This is it. What it consists? It consists of glass tube. This is your glass tube. This is your glass tube that have one of its end connected to a point where pressure is to be measured. So this is the end where the pressure is to be measured. The glass tube has this end where the pressure is to be measured, and the other end remains open to atmosphere. This is the other end which remains open to atmosphere. So this arrangement is called the simple manometer. That is the pipe flow. Here the you just connected a glass tube. So now we will see the types of manometer: piezometer, YouTube manometer, and single column meter. This piezometer, this is the piezometer. In fact, this is the piezometer. Piezometer. Now I'm coming to the next slide. You can see also this is the piezometer. So this what is piezometer? This is the simplest form of manometer used for measuring the gauge pressure. Whatever the pressure you are measuring, that is with respect to atmospheric pressure you are measuring. That's why it is the gauge pressure. One end of this manometer, that means one end of piezometer, is connected to a point where the pressure is to be measured. So this is the end where the pressure is to be measured, connected, and the other end is open to atmosphere. This is the other end that remains open to atmosphere. So this type of arrangement is called the piezometer. This is a type of manometer. One of the type of manometer piezometer is the simply it is a device that consists of a glass tube, and one end of the glass tube is connected to the point where pressure is to be measured, and the other end remains open to atmosphere. So this is called piezometer. Now the second form is, what is the second form? Second is the U-tube manometer, and third one is the single column manometer. Now we are coming to the U-tube manometer. What is this U-tube manometer? So this U-tube manometer, what is this? This consists of a glass tube bent in U shape. In the previous piezometer, it's simply a glass tube, vertical glass tube that bends at the end. But this U-tube manometer, it consists of a glass tube that has the shape of U shape, bent in U shape. So this is the U shape. You can see picture here. This is your U shape. This is like this U shape. So it is bent in U shape, one end of which is connected to a point where pressure is to be measured. So this end is connected where the pressure is to be measured, and the other end remains open to atmosphere. So this is the other end which remains open to atmosphere. So this type of arrangement is called the U-tube manometer. Now I am coming to the third one, that is the simple manometer. Simple column manometer. First one is your piezometer. Second is U-tube manometer. Now third is the single column manometer. So what is this single column manometer? See, this is the single column manometer. What is this? Is the modified form of U-tube manometer. This is the modified form in which a reservoir having a large cross-sectional area. How much large? It is about 100 times as compared to the area of the U-tube, and this connected to one of the limb of the manometer, and the other limb may be vertical or inclined. So there is two limb. With the one limb, a reservoir is connected. So you can see this is the U-tube. This is the shape of U-tube. Like this is the shape of U-tube manometer. So what this single column manometer is what? This is a modified form of this manometer. Modified form of U-tube manometer. So this is two limb. One limb is this one, and this one is your second limb. So with the one limb, a reservoir is connected. A reservoir is placed in one limb. See, having that reservoir having a cross-section area about 100 times as compared to the area of the tube. Whatever the cross-section area of tube is, about 100 times of that area, the reservoir having that much of area. So it is connected in one limb, and other limb is remains open to atmosphere, and this limb, other limb may be vertical or it may be inclined. Based on this, if it is vertical, then it is called vertical single column manometer. If this limb is inclined, then it is called inclined single column manometer. We can see the picture also for better understanding. See, this is the vertical single column manometer. This is the U-tube arrangement, and this one limb is this one, and this one is the other limb. And in one limb there is a connection or connected. This reservoir is connected. That area is larger, much larger than this area of the glass tube. It is area is about 100 times of this area. So this reservoir is connected, and the other limb remains open to atmosphere, and this is vertical. That's why it is called vertical single column manometer. This limb is vertical, other limb which is not connected to reservoir. Here the other limb that is not connected to the reservoir, the other limb is this limb is this is not vertical, this is inclined. So this is called inclined single column manometer. So this is the difference between vertical and inclined single column manometer. A single column manometer is, it is what? It is the modified form of U-tube manometer in which a reservoir is connected with the one limb. So this is the single column manometer. Now we are coming to the differential manometer. You can see in the initial slide we have said this is your types of manometer: simple manometer and differential manometer. This is three forms: piezometer, single column manometer. In fact, after piezometer, this is the U-tube manometer, then single column manometer, then single column manometer. This is three types. And now this is the differential manometer. How this differential manometer can be defined? See, this is differential manometer. What is this? In the previous slide, there is manometer. So that manometer is used to measure the pressure at a single point. Now the differential manometer is used to measure the pressure at 2 points. That is the difference of pressure between 2 points. So it is the device that used for measuring the difference of pressure between 2 points in a pipe or in a different pipes, in a single pipe or in a different pipe. So this is what? This is the differential manometer is a, this consists of the U-tube. It also consists U-tube containing, it may be the heavy liquid, it may be the light liquid also. In case of light liquid, it is called inverted differential manometer. So generally it consists of heavy liquid, which one ends are connected, one end is connected to the points whose pressure difference is to be measured. Two ends are connected to the points where pressure is to be measured. That means better you see the picture, it will be more clear to you. This is the differential manometer. You can see here, this is differential manometer, and this is the inverted differential manometer. U-tube differential manometer. So you see, here is the two pipes, and so one end of this U-tube is connected to one pipe, and the other end of this U-tube is connected to the other pipe. Both ends are engaged, not open to atmosphere. So to measure the difference of pressure between A and B, that is PA minus PB, PA minus PB. To measure the pressure difference at 2 points, this U-tube differential manometer is used. This is the U-tube differential manometer, and this is the liquid that is in the manometer, and this is the liquid that is flowing in the pipe. So there is a two different liquid. One liquid is flowing in the pipe, and this is the other liquid, generally mercury, that is flowing in the manometer. Put it in the manometer. So this is the heavy liquid. That's why it is this glass tube or U-tube is below the pipeline. If this U-tube is above the pipeline, then the liquid in the this U-tube should be the lighter liquid. Lighter liquid, that means the density of this liquid should be lesser than the density of this liquid which is flowing in the pipe. Here the liquid of this, here the density of this liquid in this U-tube manometer, U-tube differential manometer, the liquid in the U-tube is density of this liquid is higher than the density of the liquid flowing in the pipe. Here the light liquid, here the heavy liquid. Light liquid is in case of inverted U-tube manometer. So this is the inverted U-tube manometer, right? So this is the difference between U-tube differential manometer and inverted U-tube differential manometer. So this is your, now come to the definition. Now it is better to understand. So this differential manometer is a device for measuring, used for measuring the difference of pressure between 2 points in a pipe or in two different pipes. So it consists of U-tube containing a heavy liquid, generally which two ends are connected to 2 points where pressure difference is to be measured. As simple as this is. Now, next is the most common type of differential manometer are the U-tube differential manometer and inverted U-tube differential manometer. What is this? This is the most common type. There is maybe other types also. The most common type are U-tube and inverted U-tube differential manometer. So this inverted U-tube contains light liquid. It is used for measuring the difference of generally of low pressure. So this is inverted U-tube differential manometer. So this is about the your manometer. Now one manometer is called the micromanometer. Just see it. This micromanometer. What is this? This is also the instrument that works on the principle of manometer. But these are especially designed to minimize the capillary effects and meniscus reading error. So this is the important in this in micromanometer. These are especially designed to minimize the capillary effects and meniscus reading errors. So that is the reading should be more accurate. For this, it is especially designed to minimize the effect of capillary. So this is the micromanometer. So this is all about the manometers. Thank you for the attending this session. Thank you.